The screen displayed here is the program we will be using to run our gyroscope experiments. The first step is to load default settings into the program, followed by setting the initialized rotor speed to 400 RPM. Once we've set it to 400, we click OK, and now we can watch the rotor spin up to the desired speed. Next, we need to load the control program by going to the Setup menu and clicking on Control Algorithm. We load the control code from the disk and can now edit the program with our gain values we found during the controller development portion of the lab. Here we're highlighting KV, KP, and KD, being careful not to change any of their signs. We save our changes, click on Implement Algorithm, and hit OK. The gyroscope will now attempt to stabilize itself around axis number 4 by rotating the rotor around axis number 2. Even when we perturb the system with a ruler, it still manages to remain properly oriented. Now we prepare trajectory inputs to give to our gyro controller. We select a step input and setup to enter custom parameters according to the lab manual. Next, we click on Setup Data Acquisition and ensure that we are recording from command position 1, encoder position 4, and control effort 2. Now we click Execute and Run. We can see the gyroscope respond to the step input with quick and jerky motions. Now that we have recorded our data, we can use the Setup Plot menu to visualize it. We add commanded position 1 and encoder position 4 to the left axis, and control effort 2 to the right axis, and click on Plot Data. Now we save our data to a file for later use. Now we want to try a ramp input. So we select ramp from trajectory 1 and set up parameters given from the lab manual. We click OK, execute, and run. The gyroscope now smoothly moves around axis number 4 as commanded. This smooth motion is why ramp inputs are typically more useful in the real world than the jerky step inputs from before. Now that we've collected our data, we can again plot it with the Setup Plot tool. We add encoder 4 position and commanded position 1 to the left axis, and leave control effort 2 on the right axis. Now we click on Plot Data, we can also add encoder 2 velocity to the right axis as well and view that plot. Finally, we save our data to a file which will be used later on.